Hello everybody, in this video we are going to talk about linear inequalities, specifically how to write them from a verbal description and how to graph them and its solution set on a coordinate plane. So let's talk first about writing inequalities from verbal descriptions. There's actually two different ways we can do this. We can write it in slope-intercept form, and we can also write it in standard form. So depending on the information that's given to us, it is going to be easier to write it in one form versus the other. So let's talk specifically about what we need for slope-intercept form. Now, if you forgot what slope-intercept form looks like, I wrote it right here. Now notice that I wrote it as an equation, but know that it can be that equal sign can be easily replaced to make it an inequality with one of those four symbols. Okay. So for slope-intercept form, we need the slope. So that way, if they tell us how something is changing or what we're multiplying by the x, then we can use that as our slope. And then we're also going to need the b, which is the y-intercept. But when we're talking about a verbal description, we don't usually say this is the y-intercept. It's usually a starting point or an initial value. So let's go ahead and write in specifically those things that we're looking for when we're writing something in slope-intercept. All right, so when we're looking for the slope, they might say something like the rate in which something is changing. They might even say the slope, but most likely you're going to run into maybe the price per unit, the price per month, how much you're getting paid per hour, or how much an item costs. That is usually going to be tied into our slope, or the m that we're going to use for our equation. When it comes to not slope-intercept, but the y-intercept, they're going to use words like the initial value, the initial price, the fee, the one-time fee, or a starting point. So if we're talking about a savings account, then we can talk about how much money we started off the savings account, and then our slope would be how much money we're either withdrawing or depositing into that account per week or per month. So your y-intercept is going to be where the problem starts. When it comes to standard form, we're actually needing three different things in order to write it. So let's go ahead and talk about what we need for a standard form equation. All right, so if you forgot what standard form looks like, it looks like this, where we have ax plus by is equal to c. Now, a, b, and c represent actual numbers. They can be positive, negative, fractions, or decimals, depending on our situation. So if we're going to write something in standard form, these are the three things that we need. We need a variable and a value that goes with that variable, so we can call it a and x. We also need a second variable and a second value, so we can call it b and y. And then c would be considered your total amount of money that you spent. It could be the total of miles you need to run. Anything that is the total amount is going to be your c, because your a and your b will come together to be c. Okay, so with that being said, let's go ahead and look at an equation or an example so we can write our inequality in standard form. So I'm already telling you up ahead of time this one's going to be standard form, so you can see what we're looking for and how we can put them together to write our inequality. All right, so this is the word problem that we're talking about. So we're talking about Axel and Anisa, and they're going to pay for a shared memory storage on a remote internet site. Their plan allows them to upload up to 250 terabytes or less of data each month. They specifically tell us that X is going to represent the number of terabytes Axel uploads in a month, and we're going to let Y represent the number of terabytes that Anisa uploads in the same month. We're going to write an inequality in standard form to represent the situation. Then we're going to use that same inequality to determine the x and the y-intercept of the line. So because they have already given us our variables, they have specifically said that x represents the number of terabytes Axel is going to use in that month, and then y is going to represent the number of terabytes that Anisa is going to upload that month. So notice that they don't give us any other numbers other than that the plan allows for 250 terabytes or less. So that's going to determine the symbol that we're going to use. Remember, we're not doing an equation, we're writing an inequality. So we have to use one of those inequality symbols. So let's go ahead and write out some of this information and then we'll organize it into the standard form. So we're going to start off with X is the number of Axel's terabytes for that month. And then we said Y is going to be the number of Anisa's terabytes for that month. And then the other thing that they tell us is that it has to be either equal to 250 or less. So I'm going to go ahead and write less than equal to 250. So with that being said, we know that Axel and Anisa has to add up to be either equal to 250 or it has to add up to a number less than 250. So we're going to say X plus Y is less than equal to 250. This is our standard form equation. Now we're going to use it to find the X and the Y intercept, because notice that down here we have a graph that not only we have to put those X and Y intercepts, but we're going to use those 2 points to form the line and determine all the different solutions to this problem. So remember, when we're looking for the X and the Y intercept, we're going to use this table right here to represent plugging in those zeros. So we know that for something to be on the y-axis, it has to be the y-intercept, it has to go through the y-axis. So that means our X has to be 0. So notice I put a 0 right there. And then the same thing happens for the x-intercept. It has to be on the x-axis, and in order for any point to be on the x-axis, your y has to be 0. So notice that I put my zeros like that. So we're going to actually take the standard form equation. We're going to plug in these zeros not at the same time but separately so we can find our x and y values for those intercepts. So the first time I'm going to do it, I am going to plug in 0 for x. So I'm going to plug in 0 for x. And these are pretty simple equations, so there's not going to be a whole lot that we need to do. So this 0 is just going to be 0, which leaves us with y is less than equal to 250. So I'm going to put 250 right here because that is now our y value. All right, I'm going to draw a line to separate, and I'm going to do x plus 0, because this time we're replacing the y with 0 into our standard form equation. 0 is just 0, so that means we can bring down the x is less than equal to 250. And so I'm going to take this 250 and put it right here. So we didn't have to do a whole lot to find the x and the y intercept for this one, but we are going to use these 2 points to create the line on the graph below. So if you take your time right here, let's go ahead and label our axes. We know that the x represents a number of Axel's terabytes, so we're going to add that right here. And we know that the y represents the number of Anisa's terabytes, so we're going to take the y-axis and we're going to go ahead and label that. I'm actually going to turn mine. And so now I have my graph and I'm ready to take these 2 points and plot them and create the line. All right, so for this one, we have 0 and 250. So 0, and then notice that we don't have a 250, but we know it's going to be about right there. So I'm just going to go ahead and add that in there. Now the next point is 250, 0. So 250 is right here, and 0 means I don't go up or down. So what I'm going to ask you to do is go ahead and create a line, connect these 2 points, but I do want to point out that because this one has an equal to sign, it is going to be a solid line that connects them. And so the part that's different about an inequality versus an equation is that we have multiple points that can be considered part of the solution. As long as the two numbers, the x and the y, add up to be a number less than 250. So there are so many different solutions that it's just easier to represent them on a graph than to sit there and completely list them out. So it's not just the points on this line that are part of the solution, but it's everything underneath this line. So what I'm going to ask y'all to do, I'm going to use my highlighter here, but you can take your pen, your pencil, or if you are also using a highlighter, you can highlight this whole section underneath the line. Because we're talking about less than, it's going to be everything less than this line. So I'm going to just kind of fill this part in to represent that the entire solution set is any point underneath this line. So if I'm looking at that, I can pick any point in this section right here, and it would be something that is part of the solution. Anything that is not shaded or is listed above the line will not be a solution. So I definitely want to show you an example from each side. So let's go ahead and look at the graph and pick a point underneath in the shaded region, and then we're going to pick a point above it in the non-shaded region. So the first thing I want to point out about these 2 points that I selected, there's nothing special about these 2 points, except for one is in the shaded region and one is not in the shaded region. So we could have picked any one of these points here or here. There's nothing special about these two. I just happen to pick them, and so what we're going to do is we're going to plug them into our standard form equation so you can see why the shaded region is a solution and why the other point is not a solution. So I have already labeled my point 60, 100 as x and y. And so the other point is 180 and 160, also labeled x and y. So we just need to drop them into that standard form equation. So let's do that real quick. So the first thing I'm going to do is say 60 plus 100 is less than equal to 50. Well, if I add 60 and 100, it gives me 160. And now we just have to ask ourselves if this is a true statement. So it's either going to be true or it's either going to be false. 160 is not equal to 250, but it is less than 250. So for that reason, this is true. So notice that the point in the shaded region gave me a true statement. So I'm going to do the same thing with this one. We're going to drop the 180 and the 160. We're going to add them together to see if they are less than or equal to 250. So we're going to say 280 plus 160 is less than equal to 250. So all we have to do is add these two numbers to see if what they are and then compare it to the 250. All right, so this gives us 340 is less than equal to 250. So we know that 340 is not equal to 250, but we also can see that 340 is not going to be a number less than 250. So for that reason, this is false, incorrect, and it doesn't give us a true statement. That's why it's in the shaded region. So for that reason, anything underneath in the shaded is called the solution set because they are part of the solution. They are points that would make our standard form equation or any equation true. Anything not in the shaded region would make it false. And it's just easier to represent all the points on the graph versus having to write them all out. All right, we're going to look at another word problem in a different situation with different numbers, but we're running out of time in this video, so we're going to pause right here. I do recommend that you watch part 2 so you can see how we work this problem out and graph it out and represent the solution set. So I'll see you guys in the next video.